All right, so for on the coordinate axis, we're not going to be using protractor. We're actually just going to use the points, the grid itself. So what that looks like, so if you imagine I have this point here, A. Now it says I want to rotate it 90 degrees around the origin, 90 degrees around this point right here, where the x and y axis meet, the origin. If I want to rotate that 90 degrees, now just imagine that's where I would be moving this shape 90 degrees in this direction. Remember, positive means counterclockwise, and negative would be clockwise. So since I'm turning it a positive 90 degrees, I know it's going to end up in this quadrant. So remember, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. Because it's in the second quadrant and I'm rotating it 90 degrees, it's going to end up in the third quadrant. If it was in the first quadrant and rotating 90, it would end up in the second, etc. So, in this case, here's how I want you to think of it. Instead of moving the point, I want you to think about just turning the paper. So I wrote this up here, turn paper counterclockwise or to the right if it's positive, the degree I'm turning it. If it's a negative degree, I'm turning the paper clockwise or to the left. So this is positive. So if this is 1, 2, 3, 4 to the left, up 1, turn my paper, and I do the same thing, left 1, 2, 3, 4, up 1. Now that's the new location for A. That is this rotated 90 degrees. And if I look, if I drew a line through my origin, and here, notice it makes a perfect right angle. I just rotated that 90 degrees around the origin and without using my protractor. Okay, so again, just recap, I went left, I figured out the location for A. So looking at it this way, with my paper upright like this, I went left 1, 2, 3, 4, up 1. Because it's 90 degrees, I turn it one time to the right because it's positive. And I count the same, left 1, 2, 3, 4, up 1. Now let's do the same thing for B. Now if I'm rotating 90 degrees around the origin, we know it goes from the fourth to the first quadrant. Well, here's how. I go right 1, down 2. Turn my paper. Right 1, down 2. And that's B. And again, notice if I draw my point, my line through these points and the origin, it forms another perfect 90-degree angle. That's why this works. So this one, C, around 180 degrees around the origin. So if this was one turn, 180 degrees is going to be 2 turns. 270 will be 3 turns. And 360, it would end up in the same place. So 180, I'm going to turn it twice, and since it's 180, it doesn't technically actually matter whether I turn it right or left. But because it's positive, we're going to keep going the same thing. So this is, I'm going to turn it to the right then. So this is left 1, 2, 3, up 2. So left 3, up 2. Turn 1, 2. And I go again, left 1, 2, 3, up 2. And now that's the new spot for C. This one, right 1, down 1, 2, 3, 4, 5. Right 1, down 5. Turn. And I go right 1, down 1, 2, 3, 4, 5. Oops. That's D prime. And again, you can see that this is 180 degrees from there. This is 180 degrees from there. And if we measure their distances, we would see that the distance from here to here is the same as the distance from here to here, and same for C. Okay, this one. negative 270. So instead of turning it to the right, I'm going to turn it to the left. And because it's 270, I'm going to turn it 3 times. So instead of to the right, I'm going to go to the left. So I go right 1 up 2. 1, 2, 3. Right 1 up 2. Now you might say, Mr. Dorr, negative 270, isn't that the same thing as positive 90? You're right. Right 1 up 2, turn. Right 1 up 2. I get the same result. In fact, I'll do that for B. Right 1, 2, 3, 4. 1, 2, 3. Right 4 up 3. Turn 1. Right 1, 2, 3, 4. Up 1, 2, 3. And there's B prime. So negative 270 is the same thing as positive 90. And I can go ahead and connect that. And again, we would see if we connected this, this would make a perfect 90-degree angle, this would make a perfect 90-degree angle. All right, let's do a little bit of shapes here. So this, call that A, call that B, D. All right, A. Now this time I'm going around 90 degrees around the point 0, 1. So 0, left and right 0, up 1. So not the origin. This is my new rotational point, not the origin. So from A, I go right 1, 2, down 2, right 2, down 2. It's 90 degrees, positive, so I turn it to the right. And remember, right 2, down 2. 1 turn. Right 1, 2, down 2. That's a new A prime. Do the same thing for B. Right 1, 2, 3, 4. Oh, 1, 2, 3. Down 1, 2, 3. Right 3, down 3. Right 1, 2, 3. Down 1, 2, 3. That's B prime. Do the same for C. Right 1, 2. 1, 2, 3, 4, 5. Right 2, down 5. 1, 2, 1, 2, 3, 4, 5. And D, I know this is going to be right 1, down 1, 2, 3. Right down, or right 1, down 1, 2, 3. Okay. So it looks like this. All right, that is that shape rotated 90 degrees around the point 0, 1. Now for this one, it says rotate 180 degrees. So again, that means I can turn my paper 2 plate times and do the same thing. So here I go left 2, down 1, left 2, go down 1, 2 and a half. So left 2, down 2 and a half. 1, 2. Left 2, down 1, 2 and a half. That's the beginning of that spot. Okay. And then this point is left 1, 2, down 1, 2, 3, 4. Turn 2, left 2, down 1, 2, 3, 4. And then my heart, I know, does something like this. Now there's that shape rotated 180 degrees. This one, negative 270. But instead of negative 270, we know that's the same thing as positive 90. So we're just going to go with that. So this point, call that A, B, C, D, and E. C, if I turn my paper and it's positive, so I turn to the right again. So turn C if it's around the point 0, 3. So 1, 2, 3. So I'm rotating around that point. So C is actually going to stay where it's at because no matter how I rotate it, C does not move. B, on the other hand, is just left 2. So I turn my paper, left 2 is B prime. Left 4 would be A. So turn my paper, again, positive 90, so 1 rotation to the right. 1, 2, 3, 4, and that's A prime. Okay. Do the same thing here. For E, I go left 1, down 2. Left 1, down 1, 2. It's E prime. And then D is left 1, 2, 3, down 1, 2. Left 3, 1, 2, 3, down 2. D prime. And now I go ahead and connect these. So B goes to D. It looks like kind of a star thing. There we go. Again, there's that shape, rotated negative 270. So negative again would be this direction. So or positive 90, just rotate that way around that point 0, 3. Now for these, we're going to use Desmos again. And using the graphing function of Desmos, we're going to determine what rotational symmetry it has, or what rotation it has. So for the first one, it's square root of x. So down here, square root of x and negative square root of x. So use the minus sign. Square root of x. So it looks like that. So I have that shape, and I have x squared. Squared button is right there. Now, how did I get from this shape to this shape? Well, it looks like it rotated 90 degrees. Now, is that positive or negative? Well, that's counterclockwise. So counterclockwise is positive. So I rotated positive 90 degrees. And we're going to draw those. So something like this. And the other one does that. So just like we did earlier, let's say positive 90 degrees. Okay, next one. I've got x squared so when I draw that, I got y equals x squared, so it looks like this. And this one, it's telling me to rotate that 180 degrees around the point 0, negative 1. So the point 0, negative 1 is here. Well, if I rotate that 180 degrees, so kind of looks like this, I guess. 180 degrees around that point, it's going to look like this. So how far is this away? 1. So it means it has to be 1 away here. And then it forms this shape. So that is this, rotated 180 degrees around that point. Next one, absolute value of x. looks like a V. So go ahead and draw that. Looks like this. And it says rotate that negative 90 degrees around the origin. So negative 90, instead of going this direction, now it's going this direction. So this point is up one, left one. So turn to the left. Or no, turn it. So turn it like this. So I went up one, right one. So that means I go up one, right one for this point. And that point obviously stays. Do the same thing here, up one, left one. Okay, cool. I go up one, left one. Ah, notice this is going to lie on the same line. So this, my new shape, is going to look like this. Oops. So I got off camera a little bit there. So let me re-explain that. I go up one, right one. So turn it, go up one, right one. This one's up one, left one to get to this point. So I go up one, left one. And notice it's going to be on that same line. So this rotated negative 90 is going to look like that. All right. This one, negative x squared. So it's important to have the negative on the outside. So negative right here, parentheses, x squared minus 2. Minus 2. Okay? Looks like that. So down 2. And rotate 180 degrees around that point. So a lot like this one, it's one away. So I'll make this one away. It's going to look like that. Okay. 3 to the x power. 3 to the, use the a to the b. 3 to the x power. So it looks like that. And draw that. Looks like that. And it wants me to rotate that negative 180 degrees. So that means I turn it twice. So if I go up one, means I go here, go up one. And notice on this, if I'm going left to right, turn it, I need to go left to right. So it looks like I'm doing this. That's what that one's going to look like. Last one, quantity x plus 3. Oh, cubed. So again, it looks like this. Go here into the third. So it looks like that using this button. So it's over 1, 2, 3. Looks like that. And wants me to rotate that 90 degrees. So positive. So that means I'm going to turn my paper this. So this one from around the origin is left 1, 2, 3. Turn it 1, 1, 2, 3. And it does this type of shape. And there you have it. That's how you do rotational geometry on the coordinate axis. Next, we will put all these together. So we're going to put transformation, rotation, and put them into what's called composition. So stay tuned for that. Thanks.